Conditionals are simple. They're a block of code that only executes if a condition is met. Each language has slightly different syntax, but it doesn't matter for understanding the concepts of conditional blocks. To visualize conditionals, we can typically look at them as a diagram. At the top we have your code before it reaches the conditional. Then the code progresses to the condition. Most languages uses the keyword if to denote a condition. Inside the parentheses of the block contains a value that evaluates to some Boolean value, either true or false. If the condition evaluates to true, it will take the true path and then take the path inside of the conditional block. After the conditional block is finished, it will go back to the code after the conditional block. However, if the condition evaluates to false, the conditional block is never executed and it just skips to after the conditional block. Let's take a look at what this might look like in code in a language like Java. We have the start of our code. In this case, it is initializing a Boolean value to true. Next, we have the if statement containing the Boolean value that we just initialized in the parentheses. Next, we have the code inside the conditional block. Notice how the conditional block is surrounded by curly braces. This indicates to the computer where the conditional block begins and ends. Finally, we have the end of our code, which is outside of the conditional block. I also want to introduce the idea of the else block. Notice how we have a very similar diagram structure as before, but instead we have an else block which only runs if the condition inside the if statement evaluates to false. As we can instantly see, this looks very simple in code. Most of the code is actually the exact same as the last example. We have the same if block as last time, but now we see the else block following the if block. Another idea to keep in mind is what we call nested conditionals. Nested conditionals are very simply just a conditional block placed inside of another conditional block. Notice this part is the outer block, and now this part indicates the inner block. This is where learning certain syntax styles is important. Notice how we indented the inner block to make it easier to read. You don't necessarily need to do this, but this is traditionally what you would do. Keep in mind, however, certain languages will require slightly different syntax. Before I move on, there are also other things you can do with conditionals, such as else-if statements, switch statements, and many more, but some of these are language specific. The only thing you really need to know is how a conditional block works and what you can do with it. But you might be asking, how do you compare values? And the answer is, it really depends on the data type. So we ask ourselves, what is the difference between primitive data types and objects when we're comparing? Let's explore the idea of comparing primitive data types. In most languages, we have the equals equals operator, which is also known as the comparative operator. Whatever used with equals equals will evaluate to a Boolean value. For example, 5 equals 5 will evaluate to true, and 7 equals 5 would evaluate to false. You can perform this operation with primitive variables as well. If we initialize a to be 1 and then say a equals 1, that expression would evaluate to true. Keep in mind for these common misconceptions, the equals operator is not the same as the equals equals operator. One equals is known as the assignment operator. It is used to assign values to variables. Equals equals, however, is the comparison operator. Finally, certain languages have a triple equals operator, but that won't be covered here. There are other ways to compare values than equals equals. There is less than, greater than, less than or equal to, greater than or equal to, and there is the inequality operator as well, which looks like an exclamation mark next to an equal sign. This simply means not equal to. Let's take a look at how equals equals works in the computer's memory. Take a second to look at the variables that are in our memory right now. The computer essentially takes a peek inside the locker of num apples and sees that its value is 43. Next, it looks inside the locker of num pairs and sees that the value is also 43. Now we can see that the computer evaluates the expression 43 equals 43 to be true. Obviously, this is a gross oversimplification, but it is a good example for conceptualizing it. In the conditional diagram, it might look something like this. Notice how inside the parentheses of the if block, we have the same expression, num apples equals num pairs. Since we know that the expression evaluates to a Boolean value, we can place it right in the parentheses. And when the computer evaluates this value to true, it will take the path inside of the conditional block. But what happens when it comes to comparing objects? Unlike primitive variables, reference variables do not work how you might expect when you use the equals equals operator. Let's analyze two strings to do this. I know I have not explicitly introduced strings yet, but if you don't already know, they come from the string class, and they are essentially a collection of characters that are strung together. Think of this as almost like words and phrases. But the only thing that is important is knowing that strings are actually objects. Let's take another look at our memory. Our computer starts by looking inside the favorite word block. Because favorite word is actually a reference variable, the computer instead pulls the memory value where the object starts. Then the computer looks inside good words locker and pulls the value inside of it. It takes the memory address of where the object for good word begins. And the computer evaluates the expression to be false, even though favorite word and good word both have the same word inside of it. Think of it this way, the comparative operator is kind of like peeking into the locker that holds the variable. But since reference variables hold a pointer or place in memory in their locker, equals equals probably won't be a great operator to compare objects. In Java at least, the string class has a method known as the .equals method. The method essentially uses the primitive data types that make up the string to determine if the value inside the objects are the same. There are more complicated class features that you will eventually learn to make this process better, but the general idea is that if you want to compare objects from classes you create, you should create your own methods to compare the primitive values that make up your objects. This way, you will have useful data to work with when you compare your objects. Here's what this would look like in a conditional block. Inside the parentheses, we are comparing two dog objects together. Make sure you note that this .equals method that is used on the dog object is a method that you create. Objects like strings already have this method in their class, but a class you create most likely will not. And that's all you need to know to understand the very basics of conditionals and comparisons. If you enjoyed, feel free to like and subscribe. Thank you for watching.